Modifying a subset of rows in a Pandas data frame. Assume I have a Pandas data frame with two columns, A and B. I'd like to modify this data frame, or create a copy, so that B is always none whenever A is 0. How would I achieve that? I tried the following. And without success.
Use .lock for label-based indexing. The df.a == 0 expression creates a Boolean series that indexes the rows, B selects the column. You can also use this to transform a subset of a column, for example. I don't know enough about Pandas internals to know exactly why that works, but the basic issue is that sometimes indexing into a data frame returns a copy of the result, and sometimes it returns a view on the original object. According to documentation here, this behavior depends on the underlying NumPy behavior. I've found that accessing everything in one operation, rather than 1-2, is more likely to work for setting.
Here it's from Pandas docs on advanced indexing. The section will explain exactly what you need. Turns out df.lock, as 9 has been deprecated, as many have pointed out below, can be used for cool slicing/dicing of a data frame. And it can also be used to set things. So Bren's answer is saying find me all the places where df.a == 0, select column B and set it to np.nam.
Starting from Pandas 0.209 is deprecated. The right way is to use df.lock. Here is a working example. Explanation. As explained in the doc here, .lock is primarily label-based, but may also be used with a Boolean array. So, what we are doing above is applying df.lock row_index, column_index by exploiting the fact that lock can take a Boolean array as a mask that tells Pandas which subset of rows we want to change in row_index. Exploiting the fact lock is also label-based to select the column using the label B in the column_index. We can use logical, condition or any operation that returns a series of booleans to construct the array of booleans. In the above example, we want any rows that contain a 0. For that we can use df.a == 0. As you can see in the example below, this returns a series of booleans. Then, we use the above array of booleans to select and modify the necessary rows. For more information, check the advanced indexing documentation here.
For a massive speed increase, use NumPy's where function. Setup? Create a 2-column data frame with 100,000 rows with some zeros. Fast solution with NumPy.where. Timings? NumPy's where is about 4x faster.
To replace multiples columns, convert to NumPy array using .values.
This is a